Alright gang, welcome to another video. We're going to work our way through a nice quick worked example using the conservation momentum theory. Just dropped my pen there. What we've got here, we've got a car 0.75 tonne, which is 750 kilograms. It's travelling along an icy surface, it slips, it hits another stationary car of 1 tonne. So we can label these up here. So we've got this first mass, that's mass 1, and this is mass 2. So mass 1 is 750, mass 2 is 1000. And again, don't forget to check out the videos on transferring between units if you've not already done so. And this is the same for the next bit of info, which we've got is in relation to velocities. Alright, so we've got an initial velocity, so that's the initial velocity of this, is equal to 30 kilometers an hour. And then, well, there's our next bit of text, we've actually got the final velocity of that as well. Alright, so initial, and we've got the final. So what we're trying to do is we're trying to work out what the velocity of this is. Alright, so we don't know what that is yet. So we've actually got that first velocity, we'll call that velocity 2. Okay, so there's no initial velocity on mass 2, but there definitely is on here. So we'll go ahead, we'll lay that formula out. So we'll have M1 U equals M1, and we've got our final V1 plus M2 V2. Okay, so we know that we've got our first mass and we've got initial velocity. We've got these two values, so we'll go ahead and we'll put those in. So we've got 750 times u. Now we're going to have to give that some thought. So how do we go from kilometers to meters per second? That's right, we divide by 3.6. We've got 30 divided by 3.6, and that will equal 8.33. And that's going to equal the same mass, 750, times this velocity, which is that one there, and it is 5 divided by 3.6. We've got 1.39. Right, we'll put that 8.33 up there. Meters per second, meters per second. Okay, so let's stick that up. We've got 750 times 1.39. We'll close those brackets. We're going to add that to this mass, which is 1000, mass 2, and we're going to multiply that by V2, which we don't know what is yet. So we're going to go ahead, we'll put some values in. So V2 is going to equal 750 times 8.33, which gives you 6248. Alright, now I've got a positive here, so we'll take that onto the other side, and that'll be minus. And I've got a multiplication here, which is this one. I'm going to do the reverse of that, and I'm going to put that up. So I've got 750 times 1.39, so give you 1042. So we'll have 6240 minus 1000 divided by 1042, and we'll get an answer of 5.21 meters per second. Alright, and again that's a positive, which tells us that these vehicles are going to be moving in that direction, which makes sense, doesn't it? If you've got a car and you ram into another car, it would make sense that the one that's moving would push it in a different direction. But to actually get our final answer here, V2 is equal to 5.21 multiplied by 3.6 this time, because divided by 3.6 goes from kilometers an hour to meters per second, and if we go the other way, we've got 5.21 times 3.6, so we've got 18.7 kilometers an hour. Alright, so that's it, maximum velocity as that object crashes into another. Now we know eventually that they would lose velocity, they decelerate and they come to a halt, but the highest velocity in that case is 18.7 kilometers an hour. Alright, so nice and quick, nice and simple, easy momentum calculation, and hopefully that ties in with what you've learned already. Nice one, all the best, take care, and see you in the next one.